A'udhu billahi minash shaitani rajim. Bismillahir rahmanir rahim. Assalamu alaikum wa rahmatullahi wa barakatuh. Good day, students. Welcome to the fourth week of our e-learning physics class for third term. My name is Oladimeji T.A., your physics teacher. This week, the topic of discussion is going to be reflection of light at plane surfaces. Reflection of light at plane surfaces. And under this topic, we are going to look at subtopics: reflection of light by plane mirrors, formation of images in plane mirrors, effect of inclining two plane mirrors, and effect of rotating a plane mirror on the reflected ray. These are the first subtopics we are going to consider under the topic. So let's begin. First period. Reflection of light at plane surfaces. As earlier discussed, light waves undergo reflection. The nature of reflection depends on the type of surface the light is incident on. Thus, we have two types of reflection, namely regular reflection and diffused or scattered reflection. Let's look at them one by one. Regular reflection. If the reflections assures that the rays are parallel to one another and are in one direction, we have regular reflection. And these regular reflections occurs when light is incident on a polished or smooth surface. On the other hand, diffuse or scattered reflection, as the name implies, if on the other hand, the rays of light are incident on a rough surface, the rays will be reflected in different directions. This type of reflection is called diffused reflection. And the diagrams below show the two types of reflection. The first diagram shows irregular reflection. You can see that the surface is smooth and all the parallel rays that are incident on the smooth surface, they are reflected parallel to one another. So this is a regular reflection. But look at the second type of diagram. The surface is rough. So the parallel rays that are incident on the surface are scattered after reflections. They are not parallel to one another after reflection. So this is a scattered or diffused reflection. Let's proceed. Plane surfaces. Plane surfaces. A plane mirror is a perfect example of plane surfaces that is most commonly used. We look ourselves in front of a mirror at least a few times a day. In addition to the cosmetic purposes, plane mirror also have important applications in medical, industrial, and scientific fields. As the name suggests, the shape of a plane mirror is a plane area. It is made from a clear plain glass sheet, usually thin and pasted with suitable reflecting abrasive, for example, mercury, on one side. Once this pasting is done, then the glass becomes opaque. But due to the reflecting property of the abrasive, the plain glass sheet becomes a plain glass reflector or a plane mirror. Look at the diagram. You can see this is a plane mirror standing vertically. The shaded part of the plane mirror is the coated or painted part. The pasted part, the one that is painted with abrasive like mercury, while the other side is the reflecting surface. And the mirror shows an incident ray OA incident on the plane surface of the mirror at an angle of incidence P, and it is reflected along OA prime. So OA prime is the reflected ray, while ON is the normal to the surface. Q is the angle of reflection. as indicated. OA is the incident ray, OA prime is the reflected ray, ON is the normal to diffuse surface, P is the angle of incidence, Q is the angle of reflection, and MM prime is the plane mirror. So, laws of reflection of light. There are two laws of reflection. These are: 1. The incident ray, the reflected ray, and the normal at the point of incidence all lie in the same plane. And 2. The angle of incidence I is equal to the angle of reflection R. Let's explain these two laws using our diagram. Look at the incident ray OA, the reflected ray OA prime, and the normal ON, the green line. All of them lie on the same plane. They are all on the same plane. So that is what the first law of reflection is saying, that the incident ray, the reflected ray, and the normal all lie in the same plane. Then let's look at the second law. For a regular reflection like the one shown in the diagram, the angle of incidence P here will be equal to the angle of reflection Q. That is, P will be equal to Q for a regular reflection. That is, the angle of incidence is always equal to the angle of reflection. So those are the two laws of reflection. 1. The incident ray, the reflected ray, and the normal at the point of incidence all lie in the same plane. 2. The angle of incidence I is equal to the angle of reflection R. So I and R denote angle of incidence and angle of reflection respectively. But in our diagram, our angle of incidence is P, while our angle of reflection is Q. So let's look at formation of images by plane mirrors. Formation of images by plane mirror. Image formed by a plane mirror. The way a plane mirror forms an image of an object placed in front of it is illustrated in the diagram below. Let's look at the diagram. The diagram shows a plane mirror in front of which is placed an object, the candle. Now, when someone looks through the mirror now, two rays A, OA, and OB coming from the top of the object, the candle, we strike the mirror and they are going to be reflected along the two paths shown to enter the eye of the observer at point A. But when the observer looks through the mirror, the two reflected rays, when they are produced backwards into the mirror, they are going to meet at a point high behind the mirror. And that is where the observer will see the image. The image seen by the observer is a virtual image because the two rays are not actually intersected at that point I, but the two rays are produced. So we have apparent intersection of the two rays behind the mirror. Also, a ray which is normal to the mirror, on striking that mirror, is going to be reflected back along that path to the object. And when it is produced behind the mirror, it is going to intersect the other two rays at the same point high, such that the distance ON and IN will be equal to each other. So the image of the candle will now be at the point high, and this image is virtual because it is not real. It cannot be produced on the screen. So this is what is explained here. The incident rays OA and OB from the tip O of the object strikes the mirror at point A and B and are reflected as AC and BD respectively. When the point AC and BD are extended backwards, they will intersect at point I. That is why an observer at point E sees the upright image of the object as if it were located at I behind the mirror. The ray ON normal or perpendicular to the mirror is reflected by along ON. When produced, it meets the other two rays at I, shows that ON is equal to NI. This image form is a factual image because the rays do not intersect to form the image. Thus, there exist two types of images, factual image and real image. Let's look at the two images one by one. A factual image is the one that is formed by the apparent intersection of light rays. That is, when the light rays are actually intersect, we have, when the light rays are not really intersect, but they intersect when we produce them backward into the mirror, we have a factual image. That is why we normally use dotted lines. But a real image is the one that is formed by the actual intersection of light rays. One major difference between a factual image and a real image is that a real image can be cut on a screen, that is, can be produced on the screen. When the screen is placed along its path, the image will be formed on the screen. But for a factual image, it cannot be cut on the screen. You cannot produce a factual image on the screen. Now, let's look at the characteristics of the image formed by a plane mirror. Image formed by a plane mirror have the following characteristics. Number one, the image is factual. Like I explained the other time, the image is not formed by the actual intersection of the light rays. So they are formed by apparent intersection. That is when the rays are produced backward inside the mirror. So that is why we say the image is factual. Two, it is far behind the mirror as the object is in front of it. What this two is telling us is that the distance of the object in front of the mirror will also be the distance of the image behind the mirror. So how far the object is from the mirror will also be how far behind the mirror the image will be. Number three, the image is upright. That is, the way the object is placed, that is how the image will also be placed, upright. It will not the image is not going to turn upside down, so it's going to stand the way the object is standing. That's what they mean by it is upright. 4, it is the same size as the object. Yes, the size of the image will be the same thing as the size of the object. It will not be smaller than the object. It will not be bigger than the object. It's going to be of the same size as the object. And 5, it is laterally inverted. It is laterally inverted. What do they mean by lateral inversion? We can notice that when we look at ourselves in the mirror, we observe that our right hand side looks like our left hand side, and also our left hand side looks like our right hand side. That is what they mean by lateral inversion. It's going to, the right hand will appear as left hand and left hand will appear as right hand. So it is laterally inverted. So let's run through the characteristic again. The image is factual because it cannot be cut on the screen. It is far behind the mirror as the object is in front. That is, the distance of the object from the mirror will also be the distance of the image behind the mirror. 3, it is upright. It's not going to turn upside down. 4, it is the same size as the object. It will not be enlarged and it will not be diminished. 5, it is laterally inverted. That is, the right hand side appears as the left hand side. So this is where we are going to end this period. Until next period when I will come your way again this week. My name is Oladimeji TA, your physics teacher. Assalamu alaikum wa rahmatullahi wa barakatuh.